What's up, DSA? It's Mr. Maltzby. I'm so excited because this is the first time I've ever made a video for my YouTube channel that has my face in it. Also in the background, we have lovely snow, which I hope you're enjoying. I have my DSA t-shirt. You're probably asking yourself, am I going to have to look at Mr. Maltzby's face for the next 10 or 15 minutes or however long this video is? And the answer is no. No, you are not. Unfortunately, I need all of this space right here to teach the math. So say bye. I'm going bye-bye. Okay. Silliness aside, let's get started. So what we're going to do is look at this symbol. We're going to talk a little bit more about the integral symbol from Friday's class. And then we're also going to talk a little bit about some of the questions in the homework where the columns were different widths. So for example, the first one was 25, the second one was 5, the third one was 20. And then also I'm probably going to run through the homework and hit a few highlights. So really let's get to kind of the main lesson, which is the integral symbol. So first, this is our symbol from Friday's class. It's called the integral symbol. Really, just the integral symbol is the S. Let's do some pronunciation. We would say this is the integral from A to B of f of x dx. And actually, the screen you're looking at is going to be what the next pop quiz will be. And it'll probably be the day we get back. And if not that day, then the next day. And what you'll be given is the black text that you see right here and the arrows, and you just have to fill in the vocabulary. So you're going to tell me that this is the upper limit of integration. You're going to tell me that A is the lower limit of integration. There's going to be an arrow drawn to the function, and you're going to say that that's called the integrand. And there'll be an arrow drawn to the dx at the end, and you're going to tell me that's the variable of integration. So maybe you want to hit pause and just kind of jot this down. Like I said, basically the blue text, the green text, the red text, except for the parentheses, the red text, and the blue text is what you are going to put as your answers on the pop quiz when you're given this picture, this math symbol. Let's go back up, and we'll actually start on one of the homework problems. That symbol is really just a way of expressing kind of the area under a function, beneath a function, but above the x-axis, starting at a specific place on the x-axis, often that is 0, and ending at another specific place. So I took one of the questions from homework where we were given the growth rate in deer per year for a population of deer. And when I worked out this area using my graphing calculator and by using the second trace 7, what I really worked out was that the integral from 0 to 3 of 2000 e to the 0.023t dt equals 10,141.005. Right. So for the moment, let's just think of this symbol as the symbol for the amount of space here. And we write it out in a specific way. I want us to remember a couple of things, that this is basically a measurement of area. An area is the product of base, so how wide something is, and height, right? Base times height makes the area. And so that's kind of important to note that really what dx represents, this little dx represents the width of the rectangles. F of x represents the height of the rectangles. The S literally represents the word sum, that we need to add together all these base times height calculations. And then we're going to start measuring our rectangles at A, and our last rectangle is going to end at B. Right? So this is kind of a symbol for the process we've been doing in class. We've been using the function for the height. We've been calculating delta x for the base. We've been doing height times base, or base times height. And we've been adding it up, starting at a number and ending at a number. Before we look at the next lesson, we're going to talk one more thing about writing. So what I did was I worked out the area under x squared from -1 to 1 using my calculator, and it was 2/3 total. This little section's a third, and this section is also worth a third. So it's 2/3 units squared. And below are just some acceptable and unacceptable ways of writing that out. So it would be acceptable to say the integral from -1 to 1 of x squared, where x squared is in parentheses, dx equals 2/3. That's fine. For this particular function, you do not need to put the parentheses, so you can say -1 to 1 x squared dx equals 2/3, and that's fine. Here are a couple things that are unacceptable. You cannot just say the integral of x squared dx equals 2/3. It's probably obvious to you that where you start and where you stop affect the total. So the -1 and the 1 matter, right? If it was ambiguous, then it could be -2 to 2, and that's a much bigger amount. But also, this is something we're going to look at in a couple of weeks, that actually leaving off the values means something. So this actually, the integral x squared dx without any numbers right here means something, but it's not this. It means it's not the area. It means something else, and we'll save that for another day. So let's not do this. And also, let's play a little game of highlights. Remember Highlights magazine? What is wrong with this? What's wrong with this? There is no dx symbol. Besides just kind of being poor writing, the reason it's bad is if you have no dx symbol, your rectangles have no base. They only have height. You can't do height plus height plus height plus height plus height. It's got to be x squared, which sets the height, times dx, which is the base. So just make sure for monomials like x squared, you don't need parentheses, so that's fine. And let's look at one other thing about this symbol, how to write this symbol out. So I use my calculator again to work out the area from -1 to 1 for x squared plus 1. And it came out to 8/3 units squared, or square units. It would be acceptable to say, well, then the integral from -1 to 1 of x squared plus 1 quantity dx equals 8/3. That's fine. What you cannot do for a multi-term expression is leave off the parentheses. Because remember, this is supposed to represent height. So without the parentheses, the base, which is dx, is not being multiplied by the height of each rectangle. It's only being multiplied by 1. And the height is x squared plus 1. So even though, and this is also nothing. This is kind of a meaningless sentence. If you wrote this on the page, I would know for a fact that you meant this. And so it's kind of an okay mistake, but please put the parentheses there because they mean something about the process. They represent the fact that every rectangle has a height, and every rectangle's height gets multiplied by the base. And when you leave off the parentheses, you ruin that. Okay, we're going to briefly jump into the homework, and then we're going to jump back out to look at our very first thing we did last Tuesday when we got back from break. So homework due Friday when we meet again. The very first problem asked you to do a left Riemann sum using a table. And it was for the most part exactly what we've been doing in class. The row for x was the width of our rectangles, and the row for f of x was the height for our rectangles. What you have to be careful in question 4 is that every rectangle has a different delta x, which is different from our bookwork this week. The first rectangle, we draw it from 0 to 25, so it's a width of 25. But the second rectangle is only drawn from 25 to 30, so it's a width of 5. And the last rectangle is from 30 to 50, so it's a width of 20. And really what this just means is you can't factor out delta x, that you have to write base times height, base times height, base times height. You cannot do the factored version with the factored out delta x. And I just want to point out, this is okay. This is how we did it before the book work. We did even rectangles. Remember, this is actually the Coach Green problem. And this is a lot like our book work, where every rectangle has a delta x of 10, and every height is unique. So we really could have added together all of the heights and then multiplied by 10. But before we did the Coach Green problem, we did the Coltrane problem. And if you look at the Coltrane problem, every rectangle has a different width. And while it's not a very symmetric picture, right, it doesn't have kind of that beauty that even rectangles have, it still meant something. 3 times 70 plus 4 times 100 plus 1 times 120 was still an approximation for area, and that approximation represented our distance. So I just wanted to point that out, that often when you're given a table, like in the homework, check to see what the widths actually are, right? Draw the rectangles in and measure their widths. And that's fine. The homework key is going to be posted on the class website next to this video. I'm not going to go through and read aloud every single problem, but I just want to point out a few highlights. It doesn't say so, but basically every problem where they give you a function, I'm expecting you to use the features of your calculator. So, for example, this is the exact same function that we had in the earlier screen. Type this into your calculator, do the integration on your calculator, integrate from 023 2000 e to the 0.03 t dt, and that'll be 1500, which is the starting population, plus the total change in deer population. And then the other thing I want to point out is a couple of these problems where we're given velocity. The first question asks us for acceleration, which is actually the derivative of the velocity. So actually we're briefly going back to the last unit where we were in the divide business, right? In the fall we were in the divide business, we were in the derivative business. So question A is kind of a fall question, and question B is our winter/spring question. If you want, you can also just pause the video and use this to check your work without getting the file. That's fine. Question 12, I actually did without a graphing calculator. If you used your calculator, that's totally fine. But really, things like 9 to the 1/2 power are things you can work out by hand by recognizing that it's the square root of 9 cubed, or the square root of 9 cubed, which is 3 cubed, which was 27. So I actually did this all completely calculator free. If you use your calculator to help, that's fine. Basically, anywhere it says estimate on here, I want you guys doing tables or drawing in tables and making rectangles. And anywhere it gives you the function and the exact value, I want you using the calc features. Second calc number 7. All right. And like I said, you can just kind of pause this video to check your work for this homework problem. It looks like we're going to miss school Tuesday, and I'll probably do a quick little video where I just go through the warm-up. And how that'll work is you'll kind of stop, do the first page of the second handout, and then all I'm going to do on the video is work through that page and tell you what we would have discussed in class that day. So just remember, the two main things from this video were knowing that we're going to have a quiz when you get back. And the quiz is just going to be kind of the vocabulary of this symbol. And I tell you what, I'm also going to add one question on it, which is how to pronounce this. This is pronounced. You're going to have to write the sentence, the integral from a to b, f of x dx. You're going to write that out with words. And then you're just going to fill in what these things are called. The upper limit of integration, the lower limit, the integrand, the variable of integration. And then this is the integral symbol. All right, I'll see you guys when I see you. Bye. I'm waving at the camera. You can't see it right now, but I'm waving. I'm waving. Wave back. Bye.